Number 20. Is the following sequence geometric? Remember what a geometric sequence is. A geometric sequence is a sequence where there's a specific pattern. The specific pattern is you multiply the previous term by a specific value, which is called the common ratio, and to get the next term. So the common ratio must be the same for each one of these multiplications. So in other words, what do we multiply 13,122 by in order to get 4374? And same thing, what do we multiply 4374 by to get 1458? And then what do we multiply 1458 by to get 486? So to find whether this is a geometric sequence and define this common ratio, we just use a calculator and divide. So let's use a calculator, and we're just going to take the second term, which is 4374, and divide that by the first term, which is 13,122. Okay, so let's go use the calculator. Okay, so 4374 divided by 13,122. Okay, so if this is a geometric sequence, then this is our common ratio. So let's go back and let's check. Let's divide the third term by the second term. So 1458 be divided by 4374. So 1458 divided by 4374. Okay, now once we divide the third term by the second term, and that's also the same. Okay, now lastly, let's do the last one. 486 divided by 1458. So 486 divided by 1458. And it's also the same. So there, now we know that's our sequence is a geometric sequence. And this value 0.33, which 0.3 repeating, which is 1/3, is our common ratio. Okay, so is the sequence geometric? The answer is yes. And then remember that 0.3 repeating, that's our common ratio. Or in other words, that's 1/3. Okay, the next part in the direction says, if so, find the common ratio in the sixth term. We already found the common ratio. So to find the sixth term, we got to find the rule or the equation for this geometric sequence. So remember the form for geometric sequence. It's a sub n is equal to a sub 1, which is our first term, time the common ratio raised to the n minus 1 power. Alright, so we already know what the first term is. The first term is 13,122, our common ratio we've just found a few seconds ago. And then n is our variable, and then minus 1. So our rule, our equation will be a sub n is equal to 13122 times the common ratio, which is 1/3, to the n minus 1 power. So to find the sixth term, we put 6 in for n. Okay, so we just multiply it out. So 13122 times 1/3 raised to the 6 minus 1 power, or basically the fifth power. So this is when we probably want to use the calculator to multiply this out. So 13122. Whoop, too many twos. And then times 1/3. Raised to the 6 minus 1, or you just put fifth power. Right, so that will be 54. So the sixth term is, if you continue the sequence, is 54. Alright, last problem, number 21. So we want to solve this radical equation. Okay, so we already have the square root by itself on the left side. So therefore, let's get rid of the square root. So we need to square both sides. So let's square the left side. But when we square the right side, we need to square this entire quantity, x plus 3. So therefore, we need to put that in parentheses. Okay, so that means when we square the right side, we need to square or multiply x plus 3 times x plus 3. So it means we need to FOIL the right side. Okay, the left side, the square and the square root just cancel. Just leave us with x plus 15. Alright, so let's go ahead and FOIL the right side. So let's just bring down the left side, x plus 15. So FOIL, first term is x times x, is x squared. The outer term is x times 3, which is 3x. The inside term is 3 times x, is also 3x, which we need to combine these 3x to get 6x, but let's multiply the last term first. 3 times 3 is 9. Alright, so I said combine the 3x plus 3x, that's 6x. Okay, so let's go ahead and rewrite. Okay, so again, 3x plus 3x is 6x. Alright, so now we have a quadratic equation on the right side. So to solve quadratic equations, we need to move everything to one side, put it in standard form, and then solve it by factoring or grouping or quadratic formulas. Okay, but let's go ahead and move everything to one side. So let's minus x both sides. So combine that with the 6x. So that would be 5x, and also let's move the 15 also to the other side, so minus 15. So let's combine that with the positive 9. Okay, so the right side, left side, there's nothing on the left side. So the right side, we have x squared plus 5x, and then minus 6. And then we could factor this one, okay, because what times what give you us negative 6, and that would give you positive 5. Okay, that will be x plus 6 and x minus 1. And then solve. Okay, so solve each parentheses, set it equal to 0 and solve, or do the opposite. So minus 6 both sides for the first parentheses. So our first solution is a negative 6. And then our second solution is positive 1. And then we always need to check our solution. So substitute back into the original equation, both solutions into the original equation, to see whether they are solutions or they are extraneous solutions. So let's test negative 6. Okay, so substitute negative 6 back into the original equation. So negative 6 plus 15. And then equal to, see if it's equal to negative 6 plus 3. Alright, so negative 6 plus 15 is a positive 9. And then on the right side, negative 6 plus 3 is a negative 3. And then square root of negative 9 is a positive 3, which is not the same as negative 3. Okay, so therefore that x equals negative 6 is not a solution. That's an extraneous solution. Okay, now let's check the positive 1. So put positive 1 in for x, so we have square root of 1 plus 15. Is that equal to 1 plus 3? So 1 plus 15 is 16. And 1 plus 3 is 4. And the square root of 16 is 4, so 4 is equal to 4. That is correct, so therefore that's our solution.